I saw this video by Tom Stanton where he built an atmosphere-powered car using a syringe. He uses a syringe as a pneumatic spring to drive the pulley and rear wheels. I've put a link to Tom's channel below where you can find cool videos and projects which are a must watch. Being the copycat I am, I had to make my own desktop version. Oops. This car toy has been a great addition to my desk. However, it's pretty banged up now. Also, I had to make a few adjustments to this version. The rear end was flexing because of the tension between the syringe, pulley and rear wheels. This meant I had to add an extra base plate at the bottom to reinforce the entire chassis. I only had Gorilla Glue to hand, and as you can see, I made a complete mess when attaching these two pieces together. Also, I'm not a fan of how the syringe sticks out at the front, and air has somehow leaked inside the syringe, causing it to lose power. The strings I've used have also loosened over time and need replacing. It was clear it was time to rebuild this desk toy. So I went back to the drawing board and threw this one away. Kind of. I 3D printed a new base that had a few changes from the last design. Let's all just pretend that fell nice and neatly in the center of the screen. Right there. The print came out really stringy. I hoped if I rubbed it enough it would magically go away, but that didn't work. So I thought I'd deal with this issue later. I printed the rest of the parts I needed, and here they are. This is the pulley that will connect the syringe to the rear wheels. This is the bottom half of the piston that will go inside the syringe. And this is the top half which slots into the bottom half of the piston. I'm using these small cone-shaped parts to connect the string to the metal rods that spin the pulley and rear wheels. Now that I had all my newly printed parts, it was time to clean and prep them. At first, I thought I could use this rotary tool to get rid of the stringing. Clearly, I'm not using it properly, and before anyone gets mad, I switched over to this cutting tool that came with my 3D printer. And I felt as though I would cut off bits of my finger before it had any real effect on the stringing. In the end, I got fed up and started scratching and pulling on the stringing. This turned out to be quite effective, and I was happy with the end result. Next, I took out the support material from the pulley and piston. Oh, and we're just going to pretend I had the correct screwdriver to take out the support material. Once I had the new parts ready to go, I started disassembling this old version. I wanted to reuse as many parts from this version as I possibly could. Taking this desk car apart was a bit of a struggle. I mean, it felt as though it didn't want to be used as spare parts. Then, the syringe decided not to play ball when I tried to carefully remove the hot glue I used to block the top hole. In the end, I decided to cut it off and deal with plugging it up again later. I pushed the plunger down and used a set of pliers to pull it out completely. Now that I've disassembled all the parts, all that was left to do was chuck this version into the iteration box. Make no mistake, getting to this stage took a lot of iterations, which is always fun. Oh, and I decided to swap out the red wheels with these orange ones. I just thought they might look better with the orange 3D printed parts. What do you think? For the most part, the assembly was going pretty well, and this new version was starting to take shape. However, once I got to the pulley section, I started to encounter some problems. In the previous version, the chassis didn't have this central bar down the middle at the back, which I added to fix with the flexing issue on that last version. This central bar is preventing the pulley section from sliding into the mounts comfortably. I repositioned the pulley and gave it another go, and before I knew it, I ended up snapping one of the mounts. At first, I wasn't sure what to do, but then I decided to slap on some super glue and hope it would be strong enough for me to try again later. While I had the super glue to hand, I carried on with the rest of the build. I dabbed a bit of glue inside the bottom half of the piston and clipped the top half in, which fit perfectly. Then I took the rubber seal off the plunger and put it on my 3D printed piston. I was using fishing wire to wrap around the pulley and rear wheels. I made sure I cut the wire a bit longer than I needed, just in case. I fed the wire through the crimp sleeve and the piston, looping it back through into the crimp sleeve. Then I used a set of pliers to squeeze the crimp sleeve, securing it into place. I pushed the piston into the syringe and tested if everything was secure by pulling the piston back. Also, I blocked the top of the hole with my finger and tested if the piston was secured tight enough to create a vacuum inside the syringe. I made this top to hot glue onto the top of the syringe and block any airflow. I ended up pressing record after I did this step, and instead of showing you my amazing gluing skills, you get to see a quick transition from my glue station to my desk. Genius. Because the top of the syringe is blocked, when I pull the piston back, it creates a vacuum inside the syringe and the air pressure around it pushes on the syringe, including the piston, forcing it back to its natural position. It was time to give the pulley section another go, which was still a bit of a struggle, and just when I thought I had it, I broke the mount on the opposite side. At this point, I started to miss the previous version, and the memories I had with it started flooding in. But I had to keep going, so I slapped on some glue on the broken section and carried on with the rest of the build. I fed the fishing wire through the pulley, and like before, I secured it using the metal crimp sleeve that came with the fishing wire. I trimmed off the excess and pulled the wire back until the metal sleeve was hidden inside the slot I made in the pulley. While I stared at the parts I had, I couldn't stop thinking about those broken mounts and decided to print a completely new base. I increased the infill by 50%, which meant it was stronger than the last one, and I adjusted the temperature settings, which resulted in much less stringing. With this new base, I started with the pulley section, being extra careful with the mounts. Whether it was luck or my hands just started behaving, I managed to slide the part in without breaking anything. With that out of the way, I was able to carry on with the rest of the assembly. By the way, if you do want to understand the physics about this concept in more detail, check out Tom's video as he explains it a lot better than I can. You can find a link to his video below. It didn't take long before I encountered my next problem. When I tried to wind the fishing wire on the pulley, it kept unwinding and getting loose. I tried to wind the wire up a few different ways, but I couldn't get it secure enough. I ended up doing this off camera because it was just way more comfortable that way. And as soon as that was sorted, I had another problem. The cone-shaped parts that connect the wires to the metal rods were loose. This meant the wheels were spinning independently from the rest of the mechanism, preventing it from winding up. I used some super glue as a quick fix to secure the cone-shaped parts to the metal rods and left it to dry till the next day. Before recording, I gave the car a test run, and this was the result. All the wires came unwound and tangled up, and it looks like there is air leaking in through the piston top, as air had gone in and caused the piston to be stuck at this halfway point. Feeling defeated, I decided to go for a walk and get some fresh air. When I got back, I realized I was doing things wrong. I remembered last time I secured the wire between the piston and the pulley first, and then I secured the wire from the pulley to the wheels. Doing it in this order was a better way of connecting the wires for some reason. I really like the look of this new atmosphere powered desk toy. The only thing left to do now was to wind it up and take it for a spin. I wound it up all the way to test how far it could travel. I didn't measure the exact distance, but I'm pretty sure it was a little over 2 meters. Unfortunately, winding it up all the way unwound and tangled the wire all over again, which was disappointing. I'm pretty sure it was due to the way I designed this pulley. If we look at the previous version's pulley, it has more of a V-shaped feature, and I think this was preventing the wire from slipping out and getting tangled. I don't have a mechanical or engineering background to know exactly what's going on here. I'm just a guy just trying out stuff I've seen on YouTube. This was still a fun project and one I'm still learning from, and I'm keen to see what other videos I can learn and copy from. Thanks for the 5 people watching, and I guess you could like or subscribe, I don't know.